Welcome to Walkabout the Galaxy, the traveling astronomy podcast where the science is universal, the opinions are personal, and the cosplay is hit or miss. We are Strange, Charm, and Up, the Astroquarks, also known as Josh Caldwell,
Addie Dove, and Hannah Sargent.
Coming to you from the Space Track at DragonCon in Atlanta, Georgia. Remember to subscribe to us on all platforms, including Facebook, Twitter, and Instagram. Check out our shows on YouTube where you can easily skip past the stupid parts to get to the good parts, or skip past the good parts to just watch the stupid parts. You'll also love our music video, and I swear our second music video will be out very soon with vocals by the amazing Lainey Pejos and graphics by the incomparable Ilea Caldwell. You can reach us on those platforms or by sending an email to wtg@ucf.edu. Our stumper today is DragonCon. Okay.
Go on.
So for Hannah and I, this is our first DragonCon experience. Mm-hmm. And for Hannah, it's almost her first con experience of any kind whatsoever.
Yeah, this has been a lot, but it's been great.
Yeah. So now we've been here 3 days. Yeah. So what is your DragonCon jam?
Marmalade.
Yes, I mean, always marmalade. My DragonCon jam. So we're talking like, what is my favorite like fandom or type of thing to
choose.
do?
So is it a fandom or is it some other aspect of it? Is it
party?
The space track? Is it the raves?
The space track has been awesome, actually. It's been really nice to see enthusiasm for space at a convention like this, because this is very new to me and I was surprised. And it's so thank you all for being here and actually being interested in what we have to say. The parties was a big one. I got here and I wasn't really sure. I felt a bit out of place. And then I saw the music and the dancing. I was like, oh, I get it now. I'm in. So that has been great. And just everyone has been incredibly welcoming and lovely. So,
Addie, what about you?
I enjoy seeing the mix of fandoms. So, like, there's not one thing that I'm the most excited about, but it's always fun to see, like, what the big hit thing is each year that you see. Like, last year there were so many Loki variants. It was amazing.
Right.
And I like the mixed cosplay, too, where it's sort of like you create your own. It's a mix of different things. The mashups, yeah.
Like Gandalf. Have you seen
We did see Gandalf last night. That was pretty amazing.
Boba Tea was a good one.
Yes.
Yeah, I'm into that.
We've seen a bunch of Dr. Grant and Dr. Statler cosplays from Jurassic Park, and those are pretty amazing.
There have been some sexy Vaders. And I thought about leaving this zipper undone and be sexy Spock.
You show a little shoulder, very risque.
Right, yes. Yeah. Well, today we'll talk about future moon missions in our Artemis corner and check in with new JWST results in the JWST corridor. JWST, that is. But first, this episode of Walkabout the Galaxy is brought to you by liquid hydrogen. Chase those hot summer days away with a cool, refreshing glass of liquid hydrogen. Guaranteed to be colder than 20 kelvins and with a density of just 7% of that of water, LH2 won't leave you with that bloated feeling that comes with H2O retention. As an added bonus, you can combine your liquid hydrogen with LOX for a real kick in the pants. Liquid hydrogen assumes no responsibility for accidental combustion, cryogenic breakage, or Artemis rocket tank fueling leaks. Liquid hydrogen. LOX and LH2 are pressurized.
What? So what is that tagline?
At the end, there's always a tagline.
Yeah.
A real life tagline.
This one's a little bit off
Seems our like a stretch for this one.
Thing. Yeah.
What is it again?
LOX and LH2 are pressurized. My daughter is shaking her head.
Is this from the movie Deep Impact?
Yes.
Was this the line you said in the movie Deep Impact?
Thank you very much, Addie. I didn't want to say.
Are you in Deep
boast.
Impact?
I didn't want to brag
Have you
myself,
mentioned it?
But since you mentioned it, yes, that's my line from Deep Impact.
What, do you know the minute marker in the movie?
I know that on the DVD it's at the beginning of chapter 10.
Okay, perfect.
There you go. I had a little bit more hair at that time. So we have a bonus trivia actually today because of some sad news. This is in honor of Frank Drake. So Frank Drake is a pioneering planetary scientist. He died on Friday at the age of 92 and is perhaps best known for being the creator of the Drake equation. The Drake equation is the first scientific approach to estimating the number of intelligent civilizations that might be in our galaxy.
So far, still at 0?
Well, yes. And one of the factors in the Drake equation is the fraction of stellar systems that have planets. And we actually
We're getting that number. We're starting to get there.
At the time the Drake equation was created, that was like a wild guess. Sure. And now
somewhere
it's not
between
so much
1 and infinity.
Or the fraction was between 0 and 1.
Sorry, between 0 and 1. Fraction.
So he, in addition to creating the Drake equation, did the first like systematic, I'm going to check to see, let's search the radio waves to see for signals. So your first bonus trivia, which we'll just answer straight away, is what was Drake's original experiment called? And you have a multiple choice.
Okay, great.
It's always helpful.
The first is GREMP, G-R-E-M-P, an acronym.
That's an acronym.
Yes,
okay, good.
naturally. The second is Project Ozma.
Okay.
The third is Serendipity, also an acronym.
Jeez.
Project Cyclops or the Sentinel Project. What do you think?
Like the Sentinel Project is a thing. But I
Sentinel,
don't know.
yeah. So that's the obelisk in 2001 in Arthur C. Clarke's story.
Well, I really want it to be serendipity purely because I want to hear that acronym explained. We love a good space acronym and forcing words together that shouldn't be together.
Like an acronym, yeah.
It's probably very contorted.
Yeah.
Yes. So you're going with serendipity. What about you?
I'm going to go with the GREMP.
GREMP. I made up both of those acronyms.
Oh, yes.
But GREMP, I actually made it up as something like Green Men Project or something like that.
Checks out. Okay.
But it's Project Ozma, named after the Queen of Oz.
Oh.
I don't know why
in
particular, but that's what it was. But Frank Drake, a real pieneer. And as we mentioned, one of his...
Did anyone here know that, by the way?
Nice.
Thank you for not shouting it out. I appreciate that.
Nice. So that was 1960, using 26-meter telescope. And since then, of course, search for extraterrestrial intelligence has grown in scope. But now we actually know something about extrasolar planets. Ooh. And recently, JWST took the first infrared direct image of an extrasolar planet, which we see here. The thing that looks like a star, but clearly is a drawing of a star, is where the star is that has been blocked out.
Yeah. So when we do imaging with JWST and other telescopes, right, the thing we're trying to image, the planet around the star, is going to be much, much, much dimmer than the star, even in infrared, right? And so they mask it out usually somehow.
Right. So
either post-processing or for doing the processing, or actually with the telescope.
This planet is HIP 654226b.
Of course.
That's my favorite number.
It's pretty hip.
That's amazing.
I know.
It is about 100 AU from the star, so about twice as far as Pluto.
It's pretty far.
Ballparkish.
But that's good because it means you can image it better.
We can see it, yes, no coincidence. And it is about 7 times the mass of Jupiter, so it's a big planet, also making it easier to see.
It's like Planet 9 out there. Ooh.
Planet 9's actually not that big.
Okay.
Planet 9, I think...
It's more Neptune-sized or something, right?
We have a grudge against... I have a grudge against Planet 9. So that's cool. We're actually seeing pictures of these planets now. JWST also observed CO2.
Yeah, I would say this isn't the most spectacular image we've seen from JWST, but it's remarkable in its science, right? So a lot of the images we've seen are these big, beautiful panoramic images or really cool zoomed in images.
Yeah, very dramatic.
Big things.
Yeah, front page kind of cover.
They're
shots.
beautiful. They should be wall hangings. I'm sure they will be. But this is really cool science. And then another cool science that doesn't make a pretty image because it's a squiggly line, which is a pretty cool image, is this new detection of CO2 in the atmosphere of an exoplanet.
What does that tell us, having the CO2 detection? Why is that so important?
Well, maybe they've got a fossil fuel problem. I'm not sure.
I feel that.
But it's the first detection of CO2. JWST also detected water vapor in an exoplanet's atmosphere. I'm very, very excited about this technique because I believe that, unlike the radio telescope signal that Frank Drake was looking for, our best bet at seeing life somewhere is seeing oxygen signature in an exoplanet atmosphere. So now we're shaking out the capability to be able to do that and actually see signs of life in other planets' atmosphere.
Yeah, and JWST looks at exoplanets that we've already detected with other methods. So, right, JWST is being programmed to look at specific planets that we think probably. So, it looked at this one because we suspected it would be a good source to look for various atmospheric composition. And the exciting thing about the CO2 is that we now have like the resolution to actually see that there's a signal there, and to be able to detect it with like really high significance in the atmosphere.
Yeah.
So it's a really important step forward.
Yeah, the telescope is definitely outperforming its advertised capabilities. And here's another, this is maybe a little bit more of a front page
This one
type
is,
picture.
yeah, this is
so
a cool
beautiful.
picture. Yeah. So here what we're looking at, the spikes are the characteristic JWST diffraction spikes from the mirror arrangement. But those rings are real things in space. And this is, Addie, when you were likening them to tree rings.
They're like tree rings, yeah. So this is, and this is also dust, which is one of our favorite things to talk about. My favorite thing, at least. So this is like bands of dust that have been shed from one of the. So this is a binary system at the center that has one's called a Wolf-Rayet star, and one is just a really big O star, I think.
And the Wolf-Rayet star, it's a rare, big, very hot star. Much hotter at the surface than the sun. It's finished its main fuel burning, and then it starts burning helium in these shells, and it starts burning, and that sort of causes it to like belch.
Yeah. So
And
it sort of
that
puffs
stops it from doing that burning for a while. And so you're seeing these puffs of belched dust off the surface of that star
So
going
is
into
that
space.
spherical, or we just happen to be looking right on that plane?
It's quasi-spherical. As you can
Yeah.
see, it's kind of squarish.
But it's not quite spherical, partly because of the arrangement of the binary system, and partly because of our imaging.
So that other star is also producing wind, which is interacting with these belches of dust out from the Wolf-Rayet star, which gives it this sort of square corners here. But the reason we're seeing rings, if you take a soap bubble, you see the edge of it,
Yeah.
right? This I could go on a long detour about my Star Wars explosion ring rant, but we'll save that for another time.
You're welcome.
Yeah. Thank you. So, so cool stuff from JWST. It's outperforming its specs, and that takes us back to our main.
So we've traversed through the JWST corridor, and we're now at the Artemis corner.
Arrived at the Artemis corridor.
Artemis Corner has been getting a lot of attention recently, and I know we're all devastated that we didn't launch yesterday. Us not as devastated because I was here and not in Florida. So
So hopefully when we're back,
hopefully we'll
have-
actually be there.
Did you have something to do with this delay?
Yeah. So
Where were you yesterday?
I was near
at
this
that?
valve.
a few days ago.
A few days, yeah. So for those that don't know, Artemis has been scrubbed for the second time, and this time this was a new problem, and this was hydrogen. They were trying to fill up one of the rocket stages, and there was some hydrogen leaking out as they were trying to fill it in. And there is a limit of around 4%, I think, because if you have a higher concentration than 4%, then that becomes, an explosion hazard. And it was way in excess of that. So they just had to stop. It potentially could have been fixed on the launch pad, which is one of the frustrating things. So it didn't necessarily have to be rolled back. But there are other parts of the spacecraft that need to be, like batteries need to be recharged and changed. And that has to be done in the vehicle assembly building, or the VAB, that giant building where the rocket is usually housed. It's going to be rolled back. It's going to have some special attention.
And you'll get to see it launch.
Well, I hope so.
Yes.
Yeah, yay! I think so. One of the interesting things about this launch, so Artemis is the first big new rocket we've built in a really long time, right? But it's based on a lot of heritage parts, and we haven't done this before. So it's upsetting that it didn't go the first two times, right? But it's also really good because we got to work it out and we got to see what's going on with the rocket, and we have to be safe with it. And these things that we're finding now were things that they wouldn't have been able to detect during the wet dress rehearsal that they did a month or two ago, right? So it's like, well, we found it now and we didn't blow up the rocket, so that's a great step.
Yeah, and
Good job.
Good job.
Yeah, and I've been following it online because a lot of people who aren't usually as into space news, they don't understand, and they say, well, Apollo flew without a hitch. It's like, actually, no, Apollo 1 was horrendous, obviously. Apollo 13, there was disasters. There were multiple rollbacks in Apollo shuttle. This is a common thing, but no one remembers the scrubs. People remember what happens next.
Disasters and successes.
Exactly.
But scrubs, not so much.
Yeah.
And
Unless
if this
you were
goes
there
wrong,
waiting
right?
for hours
Yeah.
and hours and hours in the sun, which has happened to me
remember
more
the
than a few
scrub.
times.
Yeah.
Yeah.
I never saw a shuttle launch because I went down to Florida I wasn't living in Florida at the time, but I went down one time and stayed for like 2 weeks and still didn't get to see a launch because it scrubbed so much.
I didn't get to see my own experiment launch on the
TLC's
space
song
shuttle
is about
one time. So yeah. Anyway, it'll go. It'll be the most powerful rocket by thrust at liftoff ever. 8.8 million pounds of thrust. Saturn V is about 7.5 million
What was
pounds.
the NR1 and
Oh, that's true.
the Russian one?
Oh,
that
yes.
was more.
That's true. You're right. That was actually a previous trivia. Yeah, the N1 Soviet
N1,
rocket.
that's what it was.
Okay, so what are we going to do when we get to the moon?
Well, if we go back real quick, so we just have this graphic up for those of you who are here in the room, and for our listeners, we'll post it online. But this is the sort of swoosh graphic that NASA's been using a lot lately to sort of describe the phases of Artemis. So we're at this first little capsule here on the left, which is Artemis 1, which is just the spacecraft. It's going to test out the rocket. It's actually a really interesting mission that's much longer than typical missions will be, in that it's about 6 weeks, I think.
Yeah, they really want to stretch its capabilities so they know
Yeah.
that it can safely operate within the range when we have people on board.
And it's going to go sort of further past the moon than most of the missions will and be in this really interesting orbit. And then it'll test out everything. And then the capsule will come back. And then after that, we orbit the moon with humans. So the next capsule will have humans. And then after that, we land humans on the moon. And then past that, there's several missions that are helping build up our sort of longer term capabilities, interacting with Gateway. And in association with all of these crewed missions that are sending humans back, there are also a large number of just instrumented and rover missions that are going to be going to the surface as well to do a lot of cool science and exploration.
Which brings us to V.I.P.E.R. So some of you may have already heard of V.I.P.E.R. This is a moon rover heading to a polar region of the moon. I think it's targeted for 2025.
That's currently
24,
24.
something like that.
Once upon a time is 2023.
Yes.
But is that out the window now?
That's
It's
out the
not going
window,
2023. And V.I.P.E.R is an acronym, Volatiles Investigating Polar Exploration Rover, which I call shenanigans on, as Addie might say, on that acronym,
That one's
because it
okay.
sounds like the volatiles are doing the investigating.
They
right?
could be.
Volatiles investigating, and then what are they investigating? They're investigating a rover? I don't know. Volatiles investigating.
Do you want it to be
polar
Polar Exploration Rover for volatile investigations?
Yes,
That'd be-
curvy. Maybe there's a reason why they didn't do
Now
that.
I get it. I
Now
get
it's,
it now.
it's
Yeah,
clicking.
it
Now I
doesn't
get
work
it.
quite as well.
One way or the other.
So V.I.P.E.R is going to be searching for volatiles, but most importantly, water. That is like the most interesting volatile to lunar scientists at the moment.
Volatiles are just things that easily, when they're heated, easily are
Volatilize, otherwise known as.
Evaporate.
Evaporate, yeah.
And there's so much evidence now that there is water in the poles of the moon, and water can help us support crewed missions in terms of life support needs. But one of the biggest consumers of water will be the rocket engines that need just a lot of hydrogen and a lot of oxygen.
As we know from our sponsor.
LOX
Yeah.
and LH2, perhaps.
Exactly.
You could get from those.
So we need to really map out these water supplies, and to do that we need to have in situ measurements, because we have ideas with our remote maps in terms of like kilometer scale distribution of water, but we really need to get down to the ground and see, okay, is it on the surface? How deep is it buried? How concentrated is it? So V.I.P.E.R is going to be drilling down into different areas of the lunar poles. I think it's going to be able to move around a few kilometers, several kilometers.
Yeah, so it's a rover. It has a bunch of different instruments on it, including this really cool drill that's
Yeah.
going to take heat measurements, and it has a mass spec to do gas measurements. It has a cool neutron detector to sort of probe the subsurface.
Do you know how deep that drill will go and how it's been tested? Because we had, I'm thinking about Mars Insight
Yes.
and the famous
The
thermal
mole.
probe that was supposed to go down 5 meters,
5
I think,
meters,
15
yeah.
feet, and it went about 10 inches or so.
Yeah.
From what I understand, I can't remember the specifics of this one, but generally these rover drills are somewhere in the range of 1 to 2 meters.
Yes.
Okay.
And it's been tested a lot. So Honeybee Robotics is building that drill, and it's being tested in a vacuum chamber and in regolith and things like that. So
Yeah.
anyway,
You're confident.
I'm
No one is
Okay.
ever confident in these
Okay.
things.
That was kind of like, you're confident. Yeah. Okay. All right.
So V.I.P.E.R is going to the polar region, as we mentioned, and we put this slide up. So this is actually the full. So V.I.P.E.R is up in the top right in these images with some people for scale. It's actually a pretty big rover.
Something like a golf cart size. I've heard it described as.
Yeah, but it's got bigger wheels than a golf cart, I think. So, because it's got to get around on the moon. So.
Yeah, and it gets pretty dusty up there.
Yeah. So these people are working on, this was testing the egress from the platform it'll come down off of on the lander. But then on the bottom, this is showing the landing sites that have been proposed for the Artemis 3 mission. So the first human mission, which is also going to go to the South Pole. But one of them, the Nobile Rim, you see sort of on the left-ish, that is probably where V.I.P.E.R is going to go. Some of these things depend a lot on when the missions launch and what the trajectories for the missions are. And also like lighting conditions at the time from that, because we want to go to areas that have these icy regions, but also get sunlight at the time of the mission.
Yeah, I mean, one of the interesting things about this rover, when you look at it, the solar panels, we think of Mars rovers, the solar panels are on the top,
Yeah.
right, pointing up at the sun, which is where we're usually used to finding the sun. But
Yeah.
these are on the walls.
They're on the walls.
Yeah, 'cause-
basically, because it's cruising around near the South Pole where the sun basically doesn't rise or set. It just sort of scoots around
It's
the
like when you're in the
horizon over
poles
course of the
here
day.
and it's really low on the horizon. So it's
Yeah.
It's perpetually low in the sky, and it's going to be moving between these. So when you are on these higher flat regions, you are permanently in sunlight throughout the year.
which is good.
And then you go into a shadowed region and it's permanently in shadow. It's just below in one of these craters, and so it never sees sunlight at all. And this rover is going to be investigating these really extremes of environment and to see how stable the water is in those different stages.
Right. I mean, that's the whole point of going to the South Pole is you get this sort of miraculously,
Best of both worlds.
yeah, you get permanent sunlight and permanent darkness, and the permanent darkness can act as the cold trap for water. And we're saying water, I'm making air quotes because it's not water that you just scoop up and drink.
Probably frost.
Frost,
Things-
probably dirty frost.
Yeah,
Dirty
things. It's actually in the rocks as well.
Mm-hmm.
Yeah. So, like, the way the water gets there in the first place.
There's kind of two general explanations that are used. So there's the idea of water that is delivered to the surface of these planetary bodies,
By like comets and things like that.
and that water that comes with it, if that water then strikes one of these cold spots, it will condense there and trap down into these, and they will build up into larger and larger deposits. And then there's also water that is literally created almost in this live chemical reaction that occurs because the solar wind is literally a flow of protons, otherwise known as hydrogen, and that will interact because it's very energetic. It can interact with the rocks, which is made up of like 40% oxygen. So when you have that hydrogen reacting with this oxygen, we get more hydrogen. When you have the hydrogen and oxygen together, then you can actually just form water all over the lunar surface. But then in the cold spots is where it will collect.
Right.
And next,
Yeah, so I was just going to say, like, with the comet delivery, the comet hits, it's not like a landing, like a docking. Here's your comet, 67P, with a nice
Here's some
delivery
water.
of several tons of water. It's a violent impact, makes a crater. That water is vaporized. We're talking about volatiles. And it's hot, and it goes flying. But the moon's gravity is strong enough that a lot of those molecules then bounce back down on the surface.
And we think there could be this almost, it's weird to call it a water cycle because it's nothing like the water cycle that we have here on Earth, but this idea of these water molecules almost migrating and hopping cold spot to cold
Hopping
spot.
around, it's too hot, it's too hot, it's too hot, it's too hot, until they land in a cold spot, and then they're like, okay,
I'm cool.
I'll hang out. I'm cool, literally. Yeah. So before we talk about another lunar mission that we're very excited about, and I think Addie may have some interest in, we'll do our main trivia. Okay, so this will hold on until after the next topic. So since we're at DragonCon, we've got Dragon Trivia. Okay.
Ooh.
Your challenge is to match the dragon
no.
to the franchise.
I should have read the
Okay.
dragon book that I was given by Rain.
Yeah.
I didn't do my revision.
I don't think that would help with this.
I don't think that would help you with this particular trivia. So I'm going to list several dragons by name,
Okay.
and you need to determine which of the following franchises that dragon belongs to. Okay? Your franchise choices are Game of Thrones,
Okay.
which we got a new Game of Thrones out with dragons in it,
It's true.
Harry Potter,
Okay.
Lord of the Rings,
Okay.
where there's also a new show out that I think also has dragons in it. I haven't seen it yet.
Everything
Have you
has
seen
dragons. I haven't.
it? How to Train Your Dragon
Aw.
and Aragon. Okay, so those are your franchises.
Witcher?
I've
Here
not
are your
seen most of
dragons.
them.
Here are your dragons. Aragon is only in print, so you can see it on the bookstore shelf.
I also have not seen the book.
Yeah. Your dragons are Bewilderbeast,
Don't be disappointed in us. Sorry.
Norberta, Morgul, excuse the pronunciation, and Caligon the Black, and Valder.
I think I'm going to be thrown out of this.
Yeah. Do we get thrown out of DragonCon
yeah.
when we get all of these wrong?
No.
Okay.
You can stick around.
Is that true? Is that true? Okay.
Yeah, we'll see. We'll see. Okay, so we'll come back to those after we talk about Addie's mission to the moon.
Great. We can just think about that the rest of the time.
Right. Yeah.
So this is just a quick slide because there's not actually much to talk about yet, but I'm involved in a mission that is also going to the moon. It's called Lunar V.I.S E, which is the Lunar Vulcan Imaging and Spectroscopy Explorer. Is that one okay?
That is okay.
Okay. So it's exploring an area of the moon called the Gruithuisen Domes, which I'm also probably pronouncing incorrectly, but that's mostly how I hear it pronounced, which is more equatorial on the moon. And it's these really interesting, what are called silicic domes. So you can see the picture on the screen here. They're very sort of low and viscous domes. So they form sort of, sometimes magma flows really quickly, right, to form a volcano, or really very explosively. These sort of formed right?
Sorry, can you say that one more time?
I think, but so these are interesting because they're sort of like Mount St. Helens as an example here on Earth.
Is it
I don't think
lava?
so.
Okay.
I don't think so.
What's the other kind?
Pahoehoe.
Pahoehoe. Is it Pahoehoe?
It might be more Pahoehoe-y. I don't remember
Pahoehoe-ish.
exactly. Yeah.
Okay.
But so these are silicic domes that have really interesting materials, and they formed, we think, like a lot later on the moon than we would have expected them to. And so they're just a really interesting area on the lunar surface that can help us understand more about forming volcanoes, about the history of the moon, and by extension about the history of the Earth. And there also are some interesting signs that there might be some hydrogen and things in the surface there that could be used for resources. So we're going to send this mission to these domes. It's going to have a lander with a bunch of cameras and a bunch of wavelengths, and then a rover with also a bunch of cameras and a neutron and gamma ray spectrometer to look at the surface and determine what the materials are there and help us understand the history of the moon.
So you got 5 instruments going.
Yes.
Some on a lander, some on a rover. And
yeah.
how long does the rover rove?
We're anticipating about 10 days.
Is that 10 lunar days or Earth days?
10 Earth days.
Okay.
Yeah. So most of the missions so far to the moon are the first ones are only gonna operate during the day, the lunar day, which is about 14 Earth days.
So just to bring back to what we were saying earlier about the poles, where you can have permanent sunlight or permanent shadow. In the equatorial regions, a lunar day is around, 14 hours of sunlight and 14
days.
14 days. Sorry, 14 days of sunlight and 14 days of night.
Yes. Yeah.
And it gets quite cold, and then
night.
then things shut down.
So there's a lot of cool technology development going on right now to help things survive the night. And actually, the Chinese rover that's on the Chang'e 5, I think, that's on the South Polar region also, has survived several day-night cycles. So it shuts down at night to
Hibernates a bit.
to hibernate and conserve its power, and then it warms up and wakes up.
Right. Okay, so when is it
So
launching?
Lunar V.I.S E is supposed to launch and land on the moon in 2026. So in 4 years, I'll come back and update you.
There's going to be a lot of congestion around 24, 5, 6.
Yeah,
Everyone
exciting.
will be going to the moon simultaneously.
Congestion in the lunar area. Are you going at that time frame also?
Yeah, I've booked my ticket.
Yeah. Okay. So for Lunar V.I.S E, how many instruments are on the rover? How many instruments are on the lander?
We have 2
And-
cameras on the lander because they're mostly giving us context and scene imaging, and then also a descent camera to look at how we kick up the dust and what we do to modify the surface when we're landing.
And this is, so, we think about like Mars rovers, NASA builds them. So the Perseverance rover built at JPL, does these amazing things.
Yeah.
This rover is not being built by NASA.
No, so all of these, so the mission that we were selected for and several of these other sort of science missions are selected, they select the instruments and then they actually pair us with a commercial partner. So this is the Commercial Lunar Payload Services, CLIPS program.
So V.I.P.E.R is also on Eclipse mission
V.I.P.E.R is also on Eclipse lander. I think they're going with Astrobotics.
Yeah, that's right.
Yeah. And so it's this really interesting change in how NASA is doing things, where they're really helping develop the commercial industry that hopefully will sort of start with these NASA missions that have NASA payloads, but they can also have other commercial payloads on board at the same time. And they say, okay, well, you need this power, you need these specifications for your instruments. Here's what we can provide. So they're gonna select both the lander and a rover for our mission. And that's how it's being done and we don't know like who the provider is right now. So all of the images you see here are sort of notional.
Right. So it's an interesting thing. I mean, so first, congratulations, because you're deputy PI on a mission to the moon,
Yes.
and NASA selected your mission as one of 2 that was selected out of 30, I think, ballpark
like
that were proposed,
yeah.
and the only one to this particular target on the moon.
The other one's an interesting biology payload going to the South Polar region to explore radiation damage to biology.
So they're taking living things there and seeing how messed up it gets.
Yeah.
And
Okay.
that payload is also on a mission with the European Space Agency instrument, which I'm on the science team for.
And there's a precursor
Which-
version
Prospect.
on Artemis right
I
now.
can't keep track of it. Wait a minute. So what are you on?
Much. So there's a payload called Prospect, which is going to be on one of these. It was a guaranteed payload on this this joint biology mission to the South Pole of the Moon, and it's a European payload. It will have a drill, sampling for water as well, and that was part of my PhD project.
Okay.
To the moon.
Cool. All right. So to the moon. So we're, but these are independent of the Artemis delay that we were talking about earlier. They're
Yes,
not going.
yes.
They're not being launched on the SLS rocket.
Other missions have their own delays, so.
Yes.
Of course, yes. There are all sorts of things like that.
But they are independent of Artemis. They're
So
they're
what
in
will-
conjunction with and like to support a lot of the Artemis missions. So like as we mentioned, V.I.P.E.R is going to explore similar regions and help us understand the area before we get there.
What will the launch vehicle be for these other missions?
That is actually selected by the lander provider.
Okay.
So we don't know that either.
So this is very different. So, you know.
So basically, like we say, we have an instrument, and NASA says, okay, lander providers. So, and we define what we want, and then NASA says, okay, lander providers, what can you do? Who's going to win? And they bid. They bid for a contract to get to do this mission, and as part of that bid, they specify what rocket they're going to use, what lander they're going to use, all of
Okay.
that stuff.
Yeah. So
And
it's
then
a
and then NASA says, okay, you take it. So it's actually, and then we work with the commercial provider. So it's a very different model
mode, right?
of how NASA
So the
has done
first thing that
things.
happens is you said, here's this great science. Here's how we would do that great science. We need these 5 instruments. They need this much space. They need this much power, and so forth. And they're like, great, we love it. Now they're going out to the commercial community and saying, build we need for this mission, we need a rover and a lander.
Yep.
They got to have room for these instruments and this much power.
Yeah.
And then they're going to, so that hasn't even happened yet.
It hasn't. It'll happen next year.
One of the problems that we've had is a lot of the science teams proposing these instruments. They also, a lot of their work is landing site dependent. And sometimes, well, at least up until recently, the science teams haven't had a lot of involvement in the selection of the landing site because that's been down to the commercial landing team. And so now those discussions are being reshaped a little more so that the scientists can have more input into where they're landing. Yeah.
Cool. Cool. Exciting. Very exciting to see that go. Yeah. Are you ready for your Dragon?
Oh, no.
Yeah, I've been
Has-
mulling over it for hours. I'm ready.
You got a sneak peek?
As a reminder,
Okay.
your franchises are Game of Thrones,
Don't
Harry
judge us.
Potter, Lord of the Rings, How to Train Your Dragon, and Aragon. And your dragons are, we're going to just go, I'll list them all, then we'll go one by one.
Okay.
So Bewilderbeast, Norberta, Morgul, and Caligon the Black, and Valder.
And they're all like,
It's 1 and 1.
Sure. It is.
Okay.
I didn't have to tell you that, but
That's
it
true,
is.
you didn't.
Yeah.
Okay.
What were you going to ask, Hannah? They're all
no.
nothing. You don't want to.
Okay, what's the first one?
Bewilderbeast.
whoever said that was easy.
We heard that.
Yes. This is painful enough.
Can we get help from the audience? We could do this an audience participation one. That would help us this time.
I'm sure the audience will get
Bewilderbeast.
this 100% right.
I know. That's why I wanted to do it.
Collectively, the audience
already forgotten
will
How to Train Your
totally
Dragon.
nail this. Addie says, How to Train Your Dragon. What do you say, Hannah?
Lord of the Rings.
Lord of the Rings. It is
What is it?
How to Train Your Dragon.
I've not seen that film.
Bewilderbeast, which has some marvelous dragon names like Submaripper was one. that I just thought was cute.
Oh, that was good. Toothless. Yeah, that was
of
the one.
course. Even easier, Toothless would have been. Okay, Norberta.
Harry Potter.
Hannah whispers Harry Potter for Norberta.
I'm going to say Harry Potter also.
You're right. Okay.
I knew that one, I think.
Morgul.
Lord of the Rings.
Morgul. Lord of the Rings, you're saying?
What are the rest of our options? Lord of the Rings?
Game of Thrones, Lord of the Rings, and Aragon.
Aragon.
Okay, I'm not going to tell you till we do the other two because then you're just like, you're going to get
now
the
we know
last
it's
one,
process
right?
of elimination.
And
Okay.
Calagon the Black,
Okay. What's the other one?
Valder. The audience is laughing at you.
Game of
Not for the
Thrones?
right reasons.
And then whatever's left.
I think Valder is Game of Thrones.
Okay.
So that means I'm picking Calagon the Black for Lord of the Rings. Which
And
I don't
Calagon the Black is Lord of the Rings, but I thought you also said that for Morgul, which is...
No, I said
That was probably me.
the other
that was
one.
you that said...
She
yeah,
said it.
yeah. I think you're 0 for 5, Hannah.
No, she got one.
I got one.
She got
I'm
Harry
gonna
Potter.
ride
She
that
got
one.
Harry
Yeah,
Potter.
Harry Potter. You're
I'm going to
right,
ride that
yeah.
win all day.
Morgul is Game of Thrones, and Calagon the Black, Lord of the Rings, and Valder,
Oh.
Aragon.
I switched Aragon and the other one, Game
Yeah,
of Thrones.
yeah.
All right. Well, I got 3.
Okay, good. Before we wrap up, I just wanted to...
You did great. You got 1.
Thanks.
to
You can
touch
ride that
base.
dragon.
I just want to touch base briefly about Gateway in the Moon,
Okay.
which we didn't really talk about too much.
Yeah.
And this gets back to the human exploration of the moon.
Okay.
So we took a look at SLS.
Also, Kennedy Space Center renamed like their one of their experience things as Gateway.
Which is very
super
confusing.
Too on
Yeah.
the news.
So Gateway, I think of as like a phone booth.
Gateway is like a Superman phone booth?
Yes.
Okay. I'll allow it. Yeah, so Gateway is just like a mod. So this is, and it's the Gateway, I think, sometimes. Sometimes it's just Gateway.
I see.
And sometimes it's the Gateway.
Okay.
But anyway, so Gateway is this module that in some versions it's basically just a phone booth with some solar panels and like an engine. And in some versions it gets bigger and is more space station-y. But basically it's a big airlock.
Is it going to happen in any of the 3 Artemis missions that we outlined
If you go
at the
back to
beginning?
the swoosh
The big
image,
swoosh.
you can see, so you can see that the after Artemis
between
2,
two
but
and
before
3.
3, there's several support missions
Okay.
that will put up bits of the Gateway.
Okay.
And so one of the things to kind of explain what this is going to be, it's some sort of like human tended, not permanently inhabited, but a human tended sort of orbiting station. Phone booth, sorry.
Yeah, or maybe it's like the shed in your backyard. It's like you
Yeah.
can go
Right.
in there and get some stuff when you need to, but you don't live there.
Yeah, and this is
Sure.
because getting people to the surface is way more dangerous than having people in orbit. And so, for example, some of the...
Which is why we're having SpaceX do that for us.
But yes. But one of the experiments and things that have been done on the International Space Station is getting astronauts to like remotely control rovers from the space station on, and then those rovers would be on Earth.
Yeah.
And this is to practice the idea of having a crew on this orbiting station around the moon, remotely controlling hardware on the surface of the moon. And this is because then you've got a shorter time delay.
Right.
Between your operations. So it's kind of this hybrid between surface operations and orbiting operations.
But it's also sort of just an airlock where, because the way NASA's currently sort of planning lunar missions is that, as you mentioned, so Orion launches and puts humans into orbit, right? And then they would dock, that capsule would dock with Gateway, and then the humans would get into the Gateway and again get out in the other side, let's say, pass through into like Starship or something,
Right.
where they would then land on the surface. So the lander can operate independently of the launching vehicle and could, in theory, go from Gateway to the ground and back up again numerous times.
sort of like a way station.
Yeah.
Right. Yeah. Okay, cool. While it may have felt like waiting in line for the exhibit hall at DragonCon, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can see most of our episodes, some of our bloopers, and now silly shorts, not the kind you wear. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jurusik. Production assistance is provided by Logan Basinger. Thanks to our listeners right here at DragonCon 2022 and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Hannah Sargent.
We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.